Hi students, let us solve some questions from third year group elements. So question number 1 is match the following type of question. Compounds and formulas are given. Let us match these with the correct formulas. Kernite formula is Na2B4O7.4H2O. Borax formula is Na2B4O7.10H2O, whereas bauxite is Al2O3.2H2O. Cryolite is Na3AlF6. So 1 is D, 2 is B, 3 is A, and 4 is C. So first option is correct. Next, electronic configuration of element nihonium with atomic number 113 is. So here nihonium is the last element in 13th group elements. So last element, so it belongs to 7th period, and there should be electronic configuration like 7s2 7p1. Why? Because general electron configuration is ns2 np1. So here n represents shell, that is a period number. So last element belongs to 7th period, that's why 7s2 7p should present. Third one is the correct answer. Next, the order of abundance of third A group elements is. In third A group elements, so we know the elements present in third A, that is boron, aluminium, gallium, indium, and thallium. Among all these elements, aluminium is the third most abundant element in the earth crust. So then gallium, then boron. So option is fourth. Next, the element with same number of electrons in the penultimate and anti-penultimate shell among the third A group elements is. So penultimate shell is nothing but before valence shell is called as penultimate shell. Before valence shell is called as penultimate shell, and before penultimate shell is called as anti-penultimate shell. So here, in which of the following elements there are same number of electrons are present in penultimate and anti-penultimate shell is asking. So let us see in which there are equal number are present. So in indium, there are same number of electrons are present in penultimate and anti-penultimate shell. Let us see electronic configuration of indium. Indium atomic number is 49 and its electronic configuration is 1s2, 2s2, 2p6. Next, 3s2, 3p6, 3d10, and 4s2, 4p6, 4d10, and it belongs to 5th period, so 5s2, 5p1. So here 4th shell is called as penultimate shell. In 4th shell there are 18 electrons are present. So penultimate shell 18 electrons. Anti-penultimate shell is a 3rd shell. Here also 18 electrons are present. So equal number of electrons present in indium. Next, statement type of question. Here statement 1 is atomic radius of gallium is less than that of aluminium is said. So this is correct statement. Why? Because here we are not following the regular trend. Atomic radius of gallium is less than aluminium, correct only. The presence of 10 3d electrons offer poor screening effect for the outer electrons from the increased nuclear charge in gallium. So this statement is also correct. Both are correct. First option is right. The incorrect order of the physical properties of third A group elements is. Let us see the properties. Atomic radius. Boron, gallium, aluminium, indium, thallium. Increasing order is given. So this is correct statement, but here he is asking incorrect statement. Ionic radius of B plus 3 is less than aluminium plus 3, which is less than gallium plus 3, which is less than indium plus 3, and which is less than thallium plus 3. This is also correct statement. First one is correct, second one correct, and third one boiling point order. If you see, thallium is less than indium, which is less than gallium, which is less than aluminium, and it is less than boron. This is also correct statement. And coming to the fourth statement, that is electronegativity order is given here. Electronegativity order is thallium is less than indium, which is less than gallium, and which is less than aluminium, and this is less than boron. So this is incorrect statement. So he's asking incorrect only. That's why our answer should be fourth one. Actually, the correct order of electronegativity, if you see, so least electronegative is aluminium. After aluminium, gallium is least. Then after gallium, indium will come, then thallium, then boron. So this is the correct order of electronegativity. So option is which one? Third is correct. Sorry, fourth one is correct for this question. Next, match the physical property with the corresponding graphs is asking. So here graphs are given, that is atomic radius, ionization potential, electronegativity, melting point orders are given. So atomic radius, if you observe, atomic radius top to bottom in a group increases. Means if you observe the elements present in 13th group, boron, aluminium, gallium, indium, and thallium. So here from boron to thallium, atomic radius increases. So thallium should have more atomic radius. But here atomic radius is not following the regular trend. Is it clear? Atomic radius is not following the regular trend. Reason, why for example, aluminium and gallium, if you take, actually gallium should have more atomic radius than aluminium, but here gallium is having less radius due to increased in the volume. So for atomic radius, the correct graph you can see in the case of C. So one is C. Ionization enthalpy values, if you see, D will is correct. And electronegativity of boron is more. So in the given graphs, A is correct for electronegativity, and B is the answer for fourth one, melting point order. Next. So option is CDAB. CDAB, second one is right. Next, let us see question number 8. Statement type of question. The third A group element with highest melting point is gallium. So actually highest melting point is not gallium, that is boron. Boron has highest melting point. So statement 1 is wrong. Next, due to strong crystalline lattice, boron has unusually high melting point. Yes, high melting point of boron is because of what? It's unusually, what it is having high because of its what lattice? Crystalline lattice structure. So third is a right answer for this question. Which of the following elements exist as liquid during the summer? During the summer, gallium is existent as a liquid. Statement. Gallium is used as a thermometric liquid to measure high temperature. Yes, correct. Gallium has very high liquid range, that is 303 Kelvin to 2676 Kelvin. So this is also correct statement. So first one is right. Both are correct. Next, the most electronegative and least electronegative elements in the 13th group elements are. So here the most electronegative is boron, right? And the least electronegative is aluminium. Most electronegative is boron, least is aluminium. Second option is right. Next, in which of the following elements NS elements do not take part in bonding due to poor shielding effect of inner d orbitals and f orbitals? Both, if you consider Right, thallium is not involving because down the group plus 1 oxidation state stability increases. So thallium is more stable with plus 1 than plus 3. This is the stability order. So because of this stability order, right, here ns electrons are in what you call reluctant towards the chemical reactions. 13th one, thallium 3 plus is a strong oxidizing and changes readily to thallium plus 1. Yes, correct one. This is the correct statement. Next, 4f14 and 5d10 give poor shielding to 6s2 electrons. Yes, this is also correct statement. Both are correct. Stability of plus 1 oxidation state increases in the sequence. So stability of, yes, aluminium is less than gallium, which is less than indium, which is less than thallium, right? Thallium is more stable with the plus 1 oxidation state. Correct statement. The best oxidizing and reducing agents in the given elements is, just now we discussed best oxidizing agent is that is thallium 3 plus, and reducing agent is aluminium because it is a metal. Metals are generally acting as reducing agents. 15th one is 2.